Hi, everybody. We're going to look at the review of AP Stats Unit 2. We're going to look at comparing two variables. Now, this first video is going to talk about categorical variables. The next one that we do later on will be quantitative variables. So for categorical variables, we have to worry about, number one, how to display them. Okay. Number two, we got to be able to do some calculations with them. So I'm showing you one of the displays right now. We're looking at two-way tables, segmented bar charts. This is a two-way table right here. So we can see that I asked about dinner preference right here. So this is dinner preference. And gender. These two, dinner preference and gender, are both categorical variables. They're not numbers. I can't add them up. Male and female don't have any numbers with them. Okay, can't take an average. If you can't take an average, then you know it's a categorical variable. So now we just get frequency counts here. Now over here, I got marginal counts. So when you're talking about summing up a row or summing up a column, you get what's called marginal counts. Then you get your total down there. So if we're going to compare these two distributions, okay, if we want to compare these two distributions, maybe we want to say, well, do males like different dinners than females? So what we can do is we can compare these two in a segmented bar chart. So what we can do is we can make our bar chart right here, and I'm going to have for males, and I'm going to have one bar for males and one bar for females. And now what I'm going to do is I have to come up with what are called the conditional frequencies, conditional relative frequencies for these here. It wouldn't make sense over here to put real, actual frequencies on this side, because it just, the men's chart, the male's chart would be half as tall as the female chart. So it's better to do relative frequencies here, percentages as they go. All right, so this is going to be 20% of males. This is 50% of males. And this is going to be 30% of males. Okay, so those are the percentages of the males. Okay, that's a conditional percentage. All right, then over here, females, given that they're a female, 5 out of 100, so that's 5%. This is 20%, and this is 75%. Okay, so now I can make my segmented bar chart in the males. So I know I'm going to top out at 100, and my both bars are going to go up to 100%. So then 50 is right here, 25 is right there, 75 is right there. So again, that halving method really helps you out. If you know your maximum, just half. It's a quick way to get it. All right, so now I'm going to have to do brats. Brats is going to be my bottom segment the whole time. It's going to be my bottom segment. So I'm going to say the bottom part of my segment for males has to go up to 20%. So I don't know, 20% is right about there. And I'll call that B. All right, brats. And then chicken is going to go an additional 50%. So my 20% plus my 50% means I have to get all the way up to 70. So about 70, about right there. So this is my chicken. Okay, so that's an additional 50% from where I am. And then now the last one I've got is 30%. So that's going to take me the rest of the way. And that's my pizza. Okay. Now, typically, you're going to have to either make a key to tell people what they are, or we can label them like this. It's fine. Females, only 5% like brats, and then 20% like chicken. So that means 5% plus 20% gets me up to 35%, which is going to be somewhere right about in here. Oh, sorry, I only got to go to 25%. Sorry, my bad. 5% and 20%. So you can tell I'm too big down there. So P, let me make that better. Can only be up 1/5. So it's got to be right there. For B, now this is P. No, that's chicken, C. And then going up here, all the way to the top is P. So now somebody might say our gender. So when they ask us our gender and dinner preference associated or not, Well, they're really asking you, is the distribution different or not? Can you tell if you tell me that the gender, or if you tell me that the distribution, sorry, if you're, yeah, you're asking, is the distribution the same in both? No, it's not. They're definitely, if you tell me that it's a female, I know that they're much less likely to pick bratwurst than if it's a male or if it's a regular person. Now, the formal way to test for independence, association versus independence, is you have to, again, independence means you have to check, is the probability of brat given female the same as the probability of brat? Okay. And then also, is the probability of female given brat, is that equal to the probability of female? I have to check those two. If those two are true, then they're independent. If it's not true, then they're not independent. Well, probability of brat given female, well, how many, if we look in here, if we're in only the females, 5 out of 100. So this is equal to, this one right here is 5% or 0.05. What's the probability that somebody wants a brat? Well, now we have to take 15. We've got to say 15 out of 150. 15 out of 150 is 10%, 0.1. So now we know that if you tell me that I'm serving a female, they are half as likely to like or to want the brat than if you just told me I was serving a person. So right here, these are not equal. So since these are not equal, B and F are dependent. So that's the quick way to do that. Okay, B and F are dependent. All right, so let's see. So let's see, did we go through those things? Counts versus relative frequency. Oh, we didn't talk about overall relative frequency. Relative frequency, that just means what percentage of the total. When you talk about relative frequency, that's the percentage of the total, not the percentage of the column or not the percentage of the row. If they're talking about conditional relative frequencies, now they're talking about the percentage of the row or the percentage of the column, depending on which one they want. So let's see, this is 10 out of 150. So percentage-wise, that's 1 out of 15. So the frequency is 1 out of 15 here. Okay, relative frequency. 5 out of 150, that's going to be 1 out of 30. 1 out of 30 would be right there. Please, that marker is no good at all. Pretty cold today. All these markers might be froze. 1 out of 30. There you go. 1 out of 15. This is going to be 25 out of 150, which is going to be 1 out of 6. This is 20 out of 150. It's going to be 2 out of 15. This is going to be 1/10. And this is going to be 75 out of 150. That's 1/2. So that's your relative frequencies in that situation. Okay. All right, so let's go on to a FRQ, sample FRQ. I'm going to move this out of the way and I'm going to let you read it and pause the video and try it. Okay, so welcome back. Hopefully you didn't get too frustrated in that. So we look at this two-way tables here and it says, what's the probability that a person chosen at random from this sample, chosen at random from this entire sample, will be in the 31 out of 45 age category? So 31 out of 45 age category total is 89. So the probability of a person, so the probability of 31 to 45 age category is equal to 89, I said? Yep. 89 over 207. 207. Which, if I get that on the calculator, 89 divided by 207, 0.43. Okay, then the next one said, what's the probability that a person chosen at random from those in the sample whose incomes are over 50,000? So now I know I'm only in the column of over 50,000 will be in the 31 to 45 age category. So what they're actually asking is, what's the probability of 31 to 45 age category inside or given that they are over 50,000? Over 50,000. And I'm going to make this a little bit bigger so you can see my screen a little more now. So that's going to be a total of over 50,000. I'm just looking at this part of the population right now. That's going to be 35 over 96. So I'm going to take 35 divided by 96, and that is 0.36. So right away, so now the last one is, based on your answers to part A and B, is the annual income independent of age category for those in the sample? Explain. So now the explain part is important here. We have to convey to the reader that we understand what it means to be independent, and that check. That idea that we know that these two here would have to be the same in order for them to be independent. All right, so you got to make sure you get that. So we're going to put that in there. If events A and B are independent, probability of A given B is equal to probability of A, and probability of B given A is equal to the probability of B. Here, probability of 31 to 45 is not equal to probability of 31 to 45 given 50,000. So the two events are not independent. But we want to make sure this piece right here is important. We got to show that we know what we're talking about. We're demonstrating. Remember, we're always demonstrating our knowledge. We're not just answering questions each time. Every time we answer a question, it's an opportunity to show that reader that we know what we're talking about. All right. So one more thing here that I want to take a look at is I want to look at this segmented bar chart, and this thing here, don't worry about the question as much. I just want you to show you another segmented bar chart. And if you could read things out of there, what would that have to look like? So at 0, we can tell there's a distribution at 0. There's 6 different distributions here. And would we say they're the same or not, or how could we compare them? And I guess what I would do is I would start picking out some of the ones where it's the largest. So like at 0.28, at a pitch of 0.28 kilohertz, the negative response, or the negative part, is the largest, or we'd say that. And then we'd notice that it seems like in the positive direction, there's kind of a tie for the largest positives, and those are at 0 kilohertz, 1 kilohertz, and 15. And then in the middle, in the gaps, pretty much all of the neutrals are about the same, except for 8 kilohertz has a large neutral section. So as the largest neutral section. So I would say I would look at similarities, I would look at differences, and I would definitely point out any largest pieces and smallest pieces. Okay. Then the next video that you get, or in another video, we're going to go over relationship between two quantitative variables. Good luck, and we'll keep seeing these videos. Hopefully, have a good time.